All right, let's see how we can solve this problem. Imagine our list looks like this. To reverse this in place, we should start from the beginning, grab the first two nodes, and change the direction of the link in between these two nodes. So instead of 20 referencing 30, we wanted to reference 10. And this will remove this link because 20 will no longer reference the following node. It will reference the previous node, right? Then in the second iteration, we're going to go one step forward. So we're going to work with these two nodes. Once again, we want 30 to reference the previous node. Okay, so that's the basic idea. Now, let me revert this back and see how we can implement this algorithm. So we're going to start from the beginning. We need two variables or two references. We can call them first and second, but we already have a private field called first, so I would rather to call these previous and current. Now, in this demo, I'm going to abbreviate these to P and C. So in the first iteration, P is going to reference or point to the first node, and C is going to reference or point to the second node. Now, to change the direction of this link, we can simply set C.next to P. Do we agree on that? Because C is currently referencing the following node. Instead, we want to set that to the previous node. That's why we have this line here. So after we execute this line, this link will be removed and 20 will reference 10. Now, in the second iteration, we should work with these two nodes. But here's the tricky part. After we execute this line, we will lose track of 30 because there will no longer be a link from 20 to 30. How can we solve this problem? Well, before we execute this line, we need to keep a reference to 30 as a backup. We can call that next. So we declare another variable called next, and initially we set it to C.next. So in the first iteration, next is going to reference 30. Now, after we execute these two steps, we are ready to move one step forward. So our pointers or references will look like this. In the second iteration, C is going to reference 30 and P is going to reference 20. So once again, we'll make the current node reference the previous node. So we'll establish this link and then go one step forward. Now in the third iteration, C is not going to reference anything. That's when we stop. So let's see how we can implement this algorithm in code. We're going to start off by declaring a variable called previous. And initially we set it to the first node because before the first iteration, P should reference the first node, right? Similarly, we're going to declare another variable called current, and we set this to first, then next. So far, so good. Now we're going to loop. So as long as current is not null, we're going to go forward and reverse the direction of the links. Because in the last iteration, current is going to be here. So it's going to be null, and that's when this loop will be terminated. Now, in each iteration, first, we need to get a reference to the node after the current node. So we declare next here and set it to current.next. Then we change the direction of the link. So that is this line over here. We set current.next to point to the previous node. Finally, we need to move these pointers or references one step forward. So we can set current to the next node and previous to the current node. But there's a problem here. With this implementation, after we set current to next, previous will also reference this node over here. So we should set the previous before setting the current. Okay? We're almost done. So after we execute this logic, all these links will be reversed. But there's a problem. Our link list has two private fields, first and last, and they are referencing 10 and 30 respectively. But after we reverse this list, last should actually reference 10 and first should reference 30, right? How do we do this? Very easy. In the last iteration, P will be referencing 30. So we can use this opportunity to reset F. Let me show you. So after this loop, we set first to previous. So first will now reference 30. Beautiful. Now, what about setting the last field? Well, one way is to start over, traverse the entire list until we get to the end, and then we can set last. But this is tedious. What if our list has a million items? We want to get rid of this unnecessary traversal. How do we do this? Well, before we execute this logic, the first field is referencing 10. So we can use this opportunity to set the last field. Let me show you. So before we get into this loop, we're going to set last to first. So last will reference 10 over here. But there is a tiny problem. If you paid close attention, in the first iteration, we changed the direction of this link, right? So 20 was previously referencing 30. Now, after the first iteration, 20 will reference 10. But internally, there is still a link between 10 to 20. In other words, our list looks like this because we never cleared this link. Now, what should we do about this? Well, as you know, the last node in a linked list should not reference any other nodes. So here, when we are setting last, we can also set last.next to null. That's all we had to do. Let me remove these comments and look at this entire code. So first we set these two variables, then we set the last field. Next, we have this logic for changing the direction of the links. And finally, we set the first field. Now this code has a problem. And I see this problem in a lot of people's code, even senior developers with years of experience. This code has what I call attention deficit disorder, or ADD. You know, like people who cannot keep their attention or focus on one thing. This code has the same problem. So on the top, we're setting these variables, but we need these for this logic. So these lines are highly related and they should be next to each other. The problem we have here is that in the middle of these, we have these two lines for setting the last field. There is a disconnect here. The attention or the focus of the code is lost. Similarly, there is a disconnect between setting the last and first fields. In the middle, we have this logic for changing the direction of the links. A lot of people write code like this, and it drives me insane when I review their code. So to make this code clean, I'm going to grab these two lines and I press Shift, Alt, and down to move them down. Okay, now let's remove this white space. These lines are highly related. With this logic, we're simply changing the direction of the links. And finally, we set the last and first fields. All right, now let's test our code. So back to the main class, we have a list with 3 items. We reverse it. Let's make sure our code is working properly. So we get 30, 20, and 10. Beautiful. Now, when testing your code, you should think of different edge cases. So here we have a list with an odd number of items. What if we have a list with an even number of items? Our code's still working. Beautiful. What if we have a list with a single item? Let's test that too. We get 10. Beautiful. Now, what if we have an empty list? We get a null pointer exception. That's not good. This is happening on line 122 of our linked list class. Over here, if our list is empty, first is null, so null.next will throw an exception. To solve this problem, before all this logic, we need to do some validation. So if we can reuse our isEmpty method, if the list is empty, we can simply return. There's no need to throw an exception here because it's not the end of the world if someone accidentally tries to reverse an empty list. It's not like an invalid operation. We don't want to yell at them. So this is how we reverse a linked list in place.